we're still into those acceleration problems involving gravity. And page 59, our homework last night, no different. Okay, it's one of those group B problems involving acceleration due to gravity. So let's do this question here now on page 59. It says, the slingshot drops riders 27 meters from rest before slowing them down to a stop. How fast are they moving before they start slowing down? Sometimes the wording of questions bothers us. And for a lot of people, I think the wording of this question bothers them, and that's okay. Try to find a way around the wording of the question. If something bothers you, then visualize it. Or better, draw a picture of it. Let's draw a picture of it. Slingshot's dropping these riders 27 meters from rest, where we're going to say VI is equal to 0 meters per second. Displacement is equal to negative 27 meters as it falls from rest. And then it begins to slow them down. So let's make it another stage down here where it's slowing down. Now, what's the rate at which it's slowing down? I don't know. Does it slow it down over a distance of less than 27, more than 27? No idea. Okay, is it really quickly? Do you feel like you're really, really heavy, lots of G-forces there? Who knows? Who cares? This question is simply this part right here. Okay, what happens after it begins to slow down? We don't know. Okay, is it stopped right here or here? I don't know. I don't care. All I know is right here, it begins to slow down. That's what I care about. If we don't know anything about that, then let's pretend it doesn't exist. What do we know here? VI is 0. We know that D is equal to negative 27. We know that A is equal to negative 9.81. And what are we looking for? We're looking for VF. This is not VF after it's stopped. That's another problem. Okay, if we were analyzing this, then VF would be equal to what? 0. But that's, the green problem is different than the blue problem. The blue problem here is an object under the influence of just gravity. The green problem is it's under the influence of gravity and something, whatever it is that's slowing it down. It's two separate problems, and we're only asked to analyze one. Okay, so let's solve for VF here. We had this discussion with the other class, not about this question, but another question, but same discussion here. Look, you look at the givens here. You know what's going on with this question here. Don't worry if you can't right away figure out what equation to use. You know for sure it's a group B equation. You know it's one of the acceleration ones. It can't be V is equal to delta D over delta T. There's only 5 choices here. If you choose wrong, then you choose again. And then if you choose wrong again, then you choose again. The worst that's going to happen is you're going to choose wrong 4 times, and it's going to take you a long time to do the question, but you're going to get it. Now, every once in a while, there is not a single equation that will get you the answer right away. Every once in a while, you have to use an equation to get something, and then use another equation to get something else. If you can't find an equation to get you VF, that's okay. Get something. Use one of the equations, get something. And then, now that you have that extra something, maybe VF becomes a little bit easier to solve for. If you keep trying, it's gotta work out as long as you have your givens written down correctly and you don't make any silly mistakes. All right, which one do you want to try here? D, VI, VF, A. Which one looks like it might be the way to go here? Simon? Yeah, I think that's the one that I would use as well. Yeah, but I want people to understand that there are 4 more options. And there's probably something else that would work, or a combination of equations that would work. This is, I think, the most efficient way, but it doesn't mean it's the only way. We're solving for VF here. Now, VF is actually pretty easy to solve for here. How do you get rid of the square? Square root it. So it becomes, instead of VF squared is equal to VI squared, it becomes VF is equal to the square root of VI squared plus 2AD. Now, the other thing that I pointed out in last class, and what I want to really reiterate with you guys as well, is that we have to be able to read between the lines. Okay, we got our givens written down now. That's great. We got our equation. We can plug them in. We can solve. But getting to this point, we have to read between the lines sometimes. Okay? The slingshot drops riders from rest. it doesn't always say that it drops from rest. If this question said the slingshot drops riders 27 meters, blah, 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 then reading between the lines, we'd still know that VI is 0 meters per second, right? If it throws them, then that's something different altogether. But if it drops them, VI is equal to 0. What if I threw a ball up into the air and I wanted to find the max height? What's the read between the lines thing there? Throw it up into the air, I want to find the maximum height. No, VI isn't 0 because I'm throwing it, right? Yeah. VF would be 0 at the maximum height, right? So be prepared. Having a quiz on this tomorrow. You got to read between the lines a little bit with VI and VF. Okay, be prepared for that tomorrow. Always be prepared for that. All right, what do we got here? VI is 0. 0 squared plus 2 times negative 9.81 times the displacement of negative 27. Careful with those signs as well. Let's figure out what we got here. Let's get what's inside the square root sign first. 0 plus, let's put everything in brackets here, 2 times neg 9.81 times neg 27. And then don't forget to square root that. When we do square root it, we get probably the answer that's in the book, 23. Yep. They asked me how fast it was moving. Are we right? This is not at the end of the problem, right? This is not at the end of the ride. This is at the end of the speeding up phase of the ride, which, if we were analyzing the second phase, it would become VI, right? VI for the second phase of the ride. What if they asked me to find the velocity they were moving when they started slowing down? What would I do then? I'll give you a hint. There's not very much else to do. They asked me for how fast it's moving. So basically the speed, right? But what if they asked me for the velocity? Has it changed direction? No, so it would still be 23, right? We just stick a negative in front of it or put it down afterwards, 23 down. We'd still use the same equation. We'd still solve for speed. And then we just ourselves recognize that it had to be down. All right? Good there? Okay, let's try another one actually. Let's try this one on page 60 that talks about this clown, which is a lot like the example that we did yesterday that also talked about the clown. Clown throws the ball upwards at 10 meters per second. Find the time that it takes the ball to return to the clown's hand from the maximum height and the ball's final velocity. So to return to his hand from maximum height. So we're analyzing the trip down then, right? The ball, oh no, wait, we're analyzing the whole thing, right? No. To return to the clown's hand from the max height. So max height up here, ball falls down to the clown's hand. How long does it take? And what's the ball's final velocity there? Final velocity is 0? No, okay. So final velocity during the fall is not 0. Remember we did our demonstration with the hole puncher, right? Read between the lines. Absolutely. If you solve for B first, okay. You do whatever you want, but you're pointing that out to me, so we'll go with that, right? We'll run with that here now. Max is suggesting that we solve for B first. And he's saying we don't really have to do much to solve for B. Okay, if it starts at 10 meters per second upwards, and then slows down, and stops, and then speeds up, and reaches the ground. If it slows down from 10 to 0 over a certain distance, and then it speeds up from 0 to something over the same distance with the same acceleration, doesn't it have to be the same value? Doesn't it have to be moving at 10 meters per second down? Now, if it landed below where it started, like this, then you couldn't do that, right? But since it lands at the same height, that works fine. Yeah, the final velocity is 10 meters per second down. No calculation to do there. You could, but it's not necessary. Or now, let's do question A. If we're analyzing, if we want to find out how long it takes the ball to go from the max height to the clown's hand, then let's write down some givens for the trip down, only for the trip down. What do we got here? Well, we know that VF is 10 now, right? Actually, we'll make it negative 10. Because VI is what? 0. If we're analyzing the trip down, it starts at rest, right? Read between the lines, right? What else do we get? A, I think, is negative 9.81. And we're solving for t here, right? Oh, okay, this isn't so bad. We're just going to use that basic equation, delta v over delta t, rearrange it, get t on the top by multiplying, a comes down by dividing, becomes negative 10 minus 0 over negative 9.81, and that's going to give me about 1, I think it's 1.02 actually, 1.02 seconds. Beyond, this question is a little bit beyond the givens, right? This question is like, get what's going on, right? Understand what's going on here. Look for some read between the line things. Yeah, and then when you do that, look, the math is ridiculously easy actually in this question. It's just getting to the math that's the trick in this one. All right. Let's give you a few minutes to work on a single question on page 60. Let's have a look at question number 1 here on page 60. It says a pebble falls from a ledge that's 20 meters high. Find the velocity with which it hits the ground and the time that it takes to hit the ground here. So let's picture this, visualize it. You guys see the pebble? Is it a big pebble or a small pebble? Small, because pebbles aren't really pebbles if they're big, right? They're rocks. It's a small pebble. Is it kind of like roundish, or is it kind of like jaggedy, edgy? Oh, it's like a skipping stone. Okay, like kind of flat on one side. All right. So you drop it. Is the cliff kind of rugged, or is it kind of like? Oh, like okay. So, okay. So the ledge of a building as opposed to the ledge of a cliff. All right. Okay. Got it. You guys picture this? You picture this kind of flat rock, the edge of a building. We're going to drop it. The building's 20 meters high. Okay. What do we got here? This is a group B problem, right? What do you got here? We got VI. That's the read between the lines thing. What's the value of that? 0, because it's dropped. If it was thrown, VI wouldn't be 0. Okay, that's the read between the lines thing we got to be aware of. We're going to see that on tomorrow's quiz. What else we got? Somebody else? So what's that? Okay, so what's that? Yeah, the displacement is negative 20 meters. Negative because it ends up below where it started. This rock with 2 flat sides that we could skip into water. Right? Yeah, by rights we should, but since we're doing these gravity questions, up is always going to be positive. I'll let you get away without writing that, but we should. Yeah, you're right. We should. What else we got? Acceleration is negative 9.81, right? Because it's under the influence of just gravity. What else we got? We're looking for VF, right? The velocity with which it hits the ground. We're looking for the time. Is VF 0? No, it doesn't hit the ground at 0. After it hits, it slows down to 0. But when it hits, it's moving. And that's why it would hurt if you happen to be sitting on the ground when that rock hit. Also looking for the time that it takes to hit the ground here. All right, so what do you want to do? Pick a group B equation. Hopefully you find the one that works for you right away, but if you don't, that's okay. Let's try this one. VI squared plus 2AD. We're solving for VF here. So we're going to square root VI squared plus 2AD. But VI, we could just make that disappear if we wanted, because it's 0. 0 squared plus 2 times negative 9.81 times the displacement of negative 20. I think when we do that, we end up getting 19.8 meters per second, huh? Because It may have something to do with me being brilliant, or it may have something to do with the answer being right in front of me there, or some kind of combination of the two. All right, so that's my final. Jacob, what have I solved for there? My final what? No, I haven't solved for my final velocity. I've solved for my final speed. I want my final velocity, so by rights, I should write final velocity is either negative 19.8, or I could say 19.8 down. Why didn't I get a negative there? Shouldn't the math just work out, Cameron? No, it's not because two negatives equal positive, actually, in this case. Hold on. Or? No. Look at what I'm solving for. Final speed. Okay, I recognize that I'm not looking for speed, I'm looking for velocity. But you know what? Unless we change direction, speed and velocity are the same thing, right? Except that velocity has direction. So let's get the speed. That's fine. Even though you're not looking for it, let's get it. And then let's just ourselves add the direction. Make sense? All right, question 2 says the time that it takes to hit the ground, probably just maybe like A is equal to delta V over delta T. I think there's other options here as well, but rearrange the solve for T. The T goes up, the A goes down. Delta V is VF minus VI. Should be 19.8 something. What's the unrounded number there? 8019? What is it? Okay, that's good. Minus 0. We always want to go 4 or 5 decimal places if it's not a final answer, right? So 19.8090 minus 0 over negative 9.81. And now I'm going to try to do a little math in my head real quickly here. I'm going to say 2.02 seconds, huh? Is that right? Cameron, does that work out? All right, if that's good, let's take a look at a few questions on page 63. No. I think you guys are doing okay. I'm not gonna assign all of those. That was the original plan when I planned things out a long time ago. But I think you guys are doing okay enough that we're not going to give you 15 questions here. I would like you to do the following questions on page 63. Number 3, number 5, 6, and notice I've copied over number 10. It's out of order there, but I've copied over number 10 and put it there just so that you can see all 4 questions that I want you to do all on one page here. So 3, 5, 6, and 10, please. All right, let's have a look at number 5 here. It says a rock takes 1.575 seconds to drop 2 meters down toward the surface of the moon. The acceleration due to the gravity on the moon is what? I mean, we've done this question for the Earth pretty much, except that we have to recognize that the Earth has a different gravity than the moon. On Earth, it's negative 9.81. What is it on the moon? That's what we're trying to find. So we're looking for A here. I'm writing down my givens because we know this is a group B problem, right? We know it's a group B problem. My time interval is 1.575 seconds. My displacement is -2. You guys are doing really well now at recognizing that that's displacement and that that's a negative displacement because it ends up below where it started. Is there anything else that I have here if I read between the lines a little bit? Max, what is it? Good. VI is 0. It's dropped. If it says a rock is thrown from a certain height on the moon, then we can't say VI is equal to 0. But if it drops, then we can say VI is equal to 0. All right. We have T, D, VI, looking for A. What's probably the most logical equation to use here? Somebody said VI times T plus 1/2 AT squared. Let's write that down for a sec. VIT plus 1/2 AT squared. All right. Do we have D? Yes, we do. Do we have VI? Yes. Do we have A? Sorry? Yeah, we want to find A. And we have T. Yeah, that works, right? Yeah, I was actually going to, somebody said VI squared plus 2AD. And I was going to write that one down because honestly, that's the one that I was thinking we were going to use. We're not. We're going to use this one. But let's write that down for a second, okay? Because I almost did until I heard somebody point this one out. What happens if I try using this one? Do I have VF? No, I don't. Do I have VI? Yes. Do I have A? No. Do I have D? Yes. Am I going to get the wrong answer using this equation? What's going to happen? Two unknowns. Can I get anything from it? So what do? You could do a calculation to get VF. Sure. But the worst case scenario here is, look, we got two unknowns, we try something else, right? All right, let's rearrange this to solve for A. VIT is going to go over by, VI is 0 actually, yeah. So let's just get rid of that whole term. The 1/2 and the T squared is going to go over by, Jade? Divide it, right. We're going to divide it all at the same time. There's no reason why we have to take it over at separate steps. We can, but we don't have to. So D is negative 2.00 divided by 1/2 of T squared. You know, when I write it out, I should write it out better actually, because what you want to do here is make sure that your brackets are around everything on the bottom. When you're dividing by something, make sure there's brackets around everything that's on the bottom. 2 divided by, also don't use that half, use 0.5 times, what is that number? 1.575 squared. Makes sense how I've entered that? Brackets around the whole thing on the bottom. And I end up getting negative 1.61. And it should be 3 significant figures because I got 4 here, 3 here. Final answer is 3 digits. How many people got that? How many people got that it was negative? Good. I mean, if gravity is negative on the Earth, it's negative on the moon too. But it's only about 1/6 on the moon what it is on the Earth because the Earth is a lot lighter. It's not nearly as heavy. That's what causes gravity. So listen, you ever want to be a track star? The moon is definitely the place to go. Definitely the place to go. On the moon, you could jump 6 times higher. 6 times higher than you can on the Earth. The only problem is, it doesn't count as a world record because you're not actually in the world. It'd be a moon record. And everybody else can jump 6 times higher as well. Okay, let's take a look at number 6 here. This one says, at the beginning of a game, a referee throws a basketball vertically upward with an initial speed of 5 meters per second. What's the maximum height above the floor reached by the basketball? Starts from a height of 1.5 meters. We're not going to pay any attention to this right now. Okay, we'll deal with that later on. Starts from a height of 1.5 meters. I don't really care what height it starts from. We'll deal with that later on. Right now, I want to focus on what's really going on in this question. The referee throws the basketball up. What happens is it goes up into the air, it slows down, and stops. We're looking for the max height. So we're going to say, what's our read between the lines thing here? VF is 0, not VI is 0. VF is 0. VI is 5 meters per second. A is neg 9.81. And we're looking for the displacement again. So I'm going to let you guys solve this one and see if you can figure out, once you get the displacement, see if you can figure out why this is not the final correct answer. Okay, let's finish up number 6. So we got this game, referee's throwing the ball up into the air, speed of 5 meters per second. What's the max height? Look, we're looking for delta D. Probably the thing we're going to try here is VF squared is equal to VI squared plus 2AD. We're going to solve for delta D. If you're solving for D, VI is, yeah, if you're solving for D, what do you get rid of first there? VI squared. And how are you going to do that? Right, so we're going to say VF squared minus VI squared equals 2AD. And then what are we going to do here? We're going to divide by 2a, right? So it becomes VF squared minus VI squared over 2a equals delta D. So we're going to say 0 minus 5 squared over 2 times neg 9.81. Negative 25 divided by negative 19.62 equals 1.27 is my answer there. But what? Yeah, if we want to find out, that's the displacement of the ball above the referee's hand. If we want to find out how high it ends up going above the floor, then we have to add the height that it started at, right? So let's add 1.5 to that. And when we do that, we get 2.72 meters. Good? All right, let's have a peek at number 10. Again, we'll just write down some givens, recognize what's going on here, and then let's see if you can figure it out yourselves after that. It says, jumping straight up, how long will a red kangaroo remain in the air if it jumps through a height of 3 meters? It's a good thing this is a red kangaroo. If this is a blue kangaroo, then that would change everything in this question. What are we going to do? Like, picture this, guys. This kangaroo is jumping up into the air. We want to know how long it remains in the air if it jumps to a height of 3 meters. So it goes up and it comes back down. What's the displacement of the kangaroo over the entire trip? 0. So in other words, look at what we have here. It's a group B problem. We have a displacement of 0 and an acceleration of neg 9.81. All right. Like, what is that going to possibly do for me? How am I possibly going to find delta T from that? We can't. So here's what we want to do. We want to analyze part of this trip, half the trip, either the trip up by the kangaroo or the trip down. If we analyze the trip up, then we have another given. What would that given be if we're analyzing only the trip up? VF is 0. If we're analyzing only the trip down, then what would be our other read between the lines given? VI would be 0, right? Which do you want to do, up or down? Up, all right. Analyze the trip up. Let's say my displacement is now not 0. My displacement is 3 meters. And let's say that VF is equal to 0 meters per second. So I think we're going to say D is equal to, actually, I'm not going to say. You're going to figure this out yourself. Okay? But I will tell you that once you get the time, it's not the right answer. But you're on the right track. You got to do something with it once you get that time. See what you can do. All right, time for us to have a look here. We want to solve for delta T in this question. So we're going to say, I think D is equal to VFT minus 1/2 AT squared. But listen, we've said this a million times. If you can't figure out which equation to use, that's okay. Like, know what group of equations you're picking from. Know that it's group B, and then pick one. If it doesn't work, pick another one. If it doesn't work, pick another one. Even if you can't solve for what you're looking for, that's okay. Solve for something else. Get something. If you're lucky, it's going to be what you're looking for. If you're unlucky, then you get something else. But that's okay, because now you have something else to help you solve for what you're looking for. Okay, it falls into place if you just keep trying. If you don't give up on it, it falls into place almost every time. All right, we're solving for T here. Good news is VF is equal to 0. So we're going to take the 1/2 A over by dividing. Not because there's a subtraction there, because it's multiplied by T squared. So it becomes D over negative 1/2 A equals T squared. And then we're going to square root both sides. So T becomes equal to the square root of delta D over 1/2 A, negative 1/2 A. So D is 3 meters over negative 1/2 times the acceleration of negative 9.81. Remember what we said when you have a denominator? Make sure you put everything inside the brackets here. The calculator's 3 divided by bracket negative 0.5 times negative 9.81, and then let's end that bracket. And then let's square root that. And we get 0.782 seconds. Why is that not the answer? Because that's up. What are we looking for? Up and down. So we're going to multiply that by 2, and then we get 1.6 seconds to 2 significant digits. 1 or 2